We've basically done the previous section. I was going to do some more examples, but I figured out, you know, if you've got these, can't you do inverse sines, cosines, and tangents? You just have to know which angle based on the coordinate of it. So this is pretty much the same old stuff at the beginning, and then there's some new stuff at the end. So when they talk about harmonic motions, they're really talking about functions that involve sines and cosines. They are harmonic, they repeat themselves, right? Here is a very classic question. We've done plenty of them, so I'm not going to dwell too much on the first two. If I asked you for the amplitude, it's 3. If I asked you for the period, won't it be 2 pi over 4, which is, what, a half pi? And I think we had one question where someone brought up a homework question, and I told you how to get it. So you'll be good if you can remember this. How do you find the frequency? Can anybody remember the one example we did a while back?
Isn't it 1 over the period?
You nailed it.
Or 1 over
well
b?
done.
That's what I wrote down.
That is exactly what it is. Now, if you take that guy, it's sometimes better to write fractions in that format. It's the same thing as a half pi. Why is it better? Well, if you do 1 over something, it's called the reciprocal. Basically, turn it upside down. That's why that makes that easy, right? So if the period is pi upon 2, you turn it upside down, you get 2 over pi. That is how many times in a 1 second unit. Since these are talking about time, in a second, how many times does the cycle repeat itself? That's not even 1. That'd be a very low frequency. Now, if there's a negative there, it has no effect. If you want to find the period of this one, it's 2 pi divided by 1/3, which if you work on your calculator is 6 pi. I'll call it 6 pi over 1, so that when I do the frequency, it's 1 over 6 pi. This minus pi here, it's not the horizontal shift yet, or the phase shift, as I prefer to call it. And if you were being asked to calculate it, which you aren't in this section, strangely enough, wouldn't you have to rewrite this a little bit differently? You'd have to actually rewrite it in a rather strange form. You'd have to pull out the 1/3. How many pi go here now? You pull out the 1/3 as a common factor. What multiple of pi do I write here so that it's equivalent to that? One-third times this guy should end up being negative pi. So what do you get?
Pi.
You do. Now, if you were being asked for horizontal shift, it would be positive 3 pi. In this section, they're not doing that, so I'm not going to dwell on that anymore. And I think we've done tons of questions where they've been asked for amplitude and period. And here's 2 more questions where they also ask for frequency. So I'm going to do one last one. And the amplitude in this case is 50. The period in this case is 2 pi divided by 0.02. So if you want to figure out what multiple of pi that is, it's probably a good idea to separate this. So I'll just go to my calculator and I'll do 2 divided by 0.02, and the answer I get is 100. So the period here would be 100 pi. And then if you want to find the frequency, it's the reciprocal of that guy. Are we comfortable now about how to find frequencies? Isn't it just 1 over the period, right? The reciprocal of the period. So far, so good. So what's the new stuff? Because we wouldn't really need this. We could have stuck this in one of the earlier sections. You are going to get questions, and we're starting with the first one, is question 9, where they ask you to find a function. So they want us to create a function that looks like this, and they're going to give you some information that it has to have. And the first piece of information, they are phrasing it in a strange way, but that's what they do in physics. They tell you that the displacement is 0 at time equals 0. They also tell you that the amplitude is 9 and that the period, in this case they're telling you the period, is 3. And we are going to create a guy that looks like this. So let's start with the first one. A very weird way of phrasing it. And what you've got to realize is that a sine function looks like that, right? And a cosine, a typical cosine function, looks like that. The displacement is 0 is then basically saying the value of y. So the value of y is 0 when time is 0. Would you agree that the sine function has that property? That the y value is 0. Think of displacement as 0 as saying the y value is 0, right? At time 0. So that gives me a start. I now know it's the sine of something, not the cosine. Okay. Now the amplitude is 9. So can't we stick a 9 there? Now here's the tricky part. We need to figure out, using that 3, what number goes there. And I'll tell you, it's not 3. Okay. Now, if you wanted to calculate the period is 2 pi divided by the number that's here, right? So I'm just going to call that, what will I call that? I'll call it A, right? In this case, 4. So the period is 2 pi divided by A. Aren't we trying to find A here? The number, the coefficient of t. If you rearrange this formula, A is 2 pi divided by the period. So in this case, 2 pi divided by 3. Do you see it's kind of the same calculation, isn't it? It's 2 pi divided by something. When you know this number, you're going to find the period by 2 pi divided by this number. If you know the period, aren't you going to do it essentially the other way around? Does that make sense? Are we good with that? Right, so there's your answer. Suppose I give you another one of these. Well, I give you a question that looks like this. Telling you that the frequency is 3 over pi, that the amplitude is 2, so this is essentially a version of question 10, and displacement is 0 at time equals 0. Right, I don't want to write that sentence again, but can you imagine I wrote that sentence again up here? Since they told me the displacement is 0, right? The y value is 0 when time is 0. That means I am going to be doing a sine of somebody. So far, so good. Now the amplitude is 2. Right? They're telling me the frequency, and that is eventually going to give me the number that goes here. Now let's see what I know. Isn't the frequency 1 over the period? You agree? So far, so good. How do you think you calculate the period if you know the frequency? If I cross multiply these, the frequency times the period equals 1. If I want to find out what the period is, then don't I divide both things by the frequency? Does that help? So the period is 1 over the frequency. Now, how do I get A? Right? A is this guy. A, oh, I should put some numbers in here, shouldn't I? The period then, in this case, is 1 over that guy, right? 1 over the frequency. What is 1 over 3 over pi? What's a quick way of doing the reciprocal of 3 over pi? If you did 1 over 3 over pi, the reciprocal of it, that's what we call that, what would you get?
Pi over 3.
Agreed. Now you're going to go round in a weird circle here. To get A, don't you take 2 pi and divide it by the period? Right? So you're going to take 2 pi and divide it by 1/3 pi, or pi over 3. So the missing number here, A, is 2 pi divided by that guy. That's 2 pi divided by that guy. If you want to divide by something, don't you multiply by its reciprocal? And 3 times 2 gets you 6. We finally got the missing number, 6. Do you see how that one was a little bit convoluted? You're told a piece of information, frequency. We use the frequency to find the period. We then use the formula that the missing number A is 2 pi divided by the period. And the calculation that ended up giving us is 6. So that guy there is 6. Any questions? I don't know if that's a good sign or a bad sign. I hope it's a good sign. Okay, let's do another one then. This is a question where the amplitude is equal to 2.2, and they do that displacement 0, 0 thing again. And the other thing they tell us is that the frequency is 700. So it's going to be 2.2, the sine of somebody. To get the period, I take 1 over the frequency. Period is 1 over 700. To get the A, it's 2 pi over the period. A is what I'm calling this missing number. That's 2 pi divided by 1 over 700. So far, so good. Now, that fraction calculation can become 2 pi divided by 1/700. That's 2 pi multiplied by 700 over 1. That ends up being 1400 pi. So the number that goes in here is 1400 pi. I'll give you a little list of our formulas that we've been using. Frequency is 1 over the period. That's the reciprocal of the period. Period is 1 over the frequency. A, the guy that goes here, is 2 pi divided by period. So that's essentially the guys I've been using. Okay, make me feel comfortable that you actually know what is going on. The displacement times 0 thing is taken for granted. So you know your function is going to be sine, because all of them are. And I am going to tell you that the amplitude is 200 and that the frequency, what shall I do the frequency at? And I'll do the frequency at 200. The units for frequency are hertz, but I'll just call it 200. Okay, you got 1 minute. Find a function that has that amplitude, that frequency, and as a sine function.
I've got it.
Whoa, you were fast. Okay, and let's just take it through the working. You can tell me what to start with. Okay, since I know the frequency, what will the period be equal to? It's a fraction.
1 over 200.
And A then is 2 pi divided by the period.
Yep. 1 over
And what
200.
does that become?
That becomes 400 pi.
And you are finished. So you only really need to know a limited number of things about the waveform that you're interested in. Amplitude, very often, if we talk about sound waves, is how loud something is. You ever heard the amplitude is high? It means it's a loud sound, right? When things are harmonic, you get a note. Some notes are pleasant on the ears, others sound like a cat being strangled. But, you know, various frequencies produce various notes. And so if you know how loud you want it to be and what kind of frequency that note is, this sinusoidal curve, if you got someone to kind of sing at a constant note, I guess it would be a hum rather than a sing, this is what their sound wave would look like. And the amplitude would be this number. And the number of cycles, so a cycle is basically starting here and finishing here, right? That's one cycle. If the frequency was 200, you would get 200 of these in just 1 second. Now, I can't possibly draw 200, but you can imagine it might look like that. All sorts of things use waves. You can use waves in radar. You know, it's a different type of sound wave, or actually it's light wave, I think. Radio wave, it's radio wave, yeah. So they use a very different frequency of radio waves, and they send it and it bounces and it comes back. So what we're going to look at now is called damped oscillation. Now, the formula for damped oscillations, this is an example of it. they have this extra piece added on. And when this number is in negative power, you have a damped oscillation. If you sketch, what does this thing look like? It looks something like this. That as time goes on, the amplitude gets smaller. Now, the kind of things that do that, can you imagine bouncing a ball or something? Can you mind it goes up high and then it comes down, then it goes up high and it goes down, but doesn't it lose bounce through time? Can you imagine a sound wave as it travels through the air? Doesn't it eventually lose its energy and dissipate? So people a long way away don't actually hear it anymore. Damped oscillations happen in situations like that and others. And so the kinds of questions you're going to be asked is to take this equation and to sketch what it looks like. And let's see if I can make that happen then. I should have, where is it? I know I had it somewhere. Okay. You hold on a few moments. I need to go finding something I thought I had. I'm going to get decimals. And when we sketch it, it should look something like that. So, there we go. If you can hear growling in the background, it's our puppy pestering. Where's Desmos? God Himmel, where is Desmos? That is weird. Can we find Desmos? There we are. Okay. For some reason it's not in. Have any of you been and looked to Canvas? Did I ever have Desmos on it? I thought I had. Did I, Alec?
I thought so.
I thought so. I can't find it right now. I've got another version. I'll make sure I put it back on. Maybe it gets deleted for some reason I can't think of. Right. Let's put in an example of what we just typed in here. So y equals e to the power of a negative 0.2 t, and get out of there. So that's basically what the e thing looks like. If you then factor in a cosine and put in 6 pi makes pi happen t. There you go. Now I'm going to just change things a little bit and zoom in a little bit, because since the axis is time, we'll assume that you only start at 0. There. Can you see the cosine shape getting lower and lower and lower? And if I zoom out the way and shift this way, can you see it basically eventually dissipates to nothing? And that's what a damped oscillation looks like. And that's pretty much it. I don't think there's really anything else in that.
Will we end up finding that curve, like, or the distance between the oscillations?
So, what was the beginning of what you said, Jacob?
The curve, like how the angle of the curve when it goes down. Will we end up having to find that?
No.
Okay.
No. You're essentially just going to be looking at one of these guys and sketching it, and you've got 5 pictures to pick, and you pick the right one.
Okay, thank you.
So if I go in and I actually show you an example of one of those questions, right? Are you looking at the homework question right now? Whoops, it disappeared for some reason. Okay. There we go. Can you see the damped oscillation guy? Looks like this. And one of those pictures we had looked like one of these four. Do you see it's that one? Do you see how this one started at the origin and then damps away, but the one that was in our graph started at a number and then it kind of dissipated. So they call this 6, 1.5, and 2. And so when you look at these guys, you just put in the numbers in the places that they're meant to go. And if they tell you F is 2, which they do, basically can't you figure out what that fella is because of, if I tell you the period, can't you calculate the A value? So essentially they're just telling you the frequency. And then once you know the frequency, you find the A, and that's where that 4 pi came from. And the other two numbers are 6 and 1.5, so they don't change. So let me kind of start one of those questions on my own. And that's pretty much going to be that part for today. So let's suppose I give you a damped oscillation, and it's called K e to the negative ct cosine of omega t, right? And I tell you that K is 30, that C is 10, and F is equal to 40. Now, we can put down, I wouldn't call that K, wouldn't you call that amplitude if you were in charge of this question? So I'm telling you the amplitude is 30. This guy, you can call it C or any letter there. So that's negative T. And we have got this fella, and it's called omega T. I've been calling that guy A today. So let's keep calling him A. If you're told the frequency is 40, then doesn't that make the period 1 over the frequency 1/40th? And doesn't that make A, they're calling them omega, 2 pi divided by the period, 2 pi divided by 1/40th, eventually you get 80 pi. Now, that's the guy you'd plug into Desmos, and then you'd look at the 4 pictures, and one of them would look like that, right? Are we good? So if I gave you this kind of information and this formula, would you feel comfortable about creating this? And then putting it into Desmos to see what it looks like?
Yes.
We good? Right.
Yeah. Actually, I have a question though.
Go for it.
Are we allowed to use Desmos on our midterm?
Yes. In fact,
Okay. Thank you.
I'm going to show you, since we finished a little bit earlier today, and that's fine. I want to show you a few things. And where the heck are you? Oh, here we go. Right. I'm going to nip over and show you our Canvas site. And there should be a guy floating around. There it is, good. I wonder if I deleted it accidentally. I will definitely make sure Desmos is in here. In fact, right now it's just a placeholder for it. But you see this guy at the bottom, which is practice midterm exam with solutions. So what I've put here is an example of some of the kinds of questions, but not all, that you're likely to see in your midterm. So are you looking at my Canvas? Have I got that page up?
Yeah.
Okay, so if I click on this one, hopefully, you know, the way things work, it goes weird on me. You should be seeing in a little while. I'll click on that. There we go. Well, you know, in Canvas, about 6 days from now, this will load up, but it should load up by now already. Did I double click? There we go. I double click. Yeah. make this a little bit easier for me to read. So I'll go make that nice and big and open that up to a full one. So when you turn up for your midterm, it's going to be on a PDF, just like this one. And it's going to have a number of questions. And there are going to be questions which are multiple choice. And when it's multiple choice like this, you just give me the answer, right? Just like you would do in WebAssign. So I've kind of took out the middleman in WebAssign, right? And I've gave you this. And I've made my life a little bit easier because it must be one of these answers, right? But I don't need to see any working for that. So all you will do is on your piece of paper that you're going to take a picture of, question one is C, question two is E, question three is D, and so on. So first, all good. Just pick one at random then. The exact value of the sine of 30 plus the cosine of 120. If you were going to do that question, wouldn't you have to use this guy? So have a good copy of a unit circle in front of you. I'm looking up the cosine of 30, which is √3 upon 2. And I'm adding the cosine of 120, and the cosine of 120 is -1/2. So you put that together, you get square root of 3 take away 1/2. And the square root of 3 take away 1/2 happens to be question C. So you would just write down C. Are you comfortable with that? Right, so you get some questions. There's a few, well, there's a lot. There's 20 here. You're not going to get 20 in your midterm. You know, you don't have enough time to do 20 questions in anything, right?
About how many questions do you think the midterm will have?
I don't know yet because I'm only going to make it over the weekend. I mean, I could give you a guess and be way out. You'll probably get about 10 multiple choice because that's a nice round number for me to do. But the multiple choice questions should only take you a couple of minutes to do at most. You know, the one that I just did there took what, 30 seconds? So if you see a multiple choice question and you think you're going to have to do a whole load of stuff to get the answer, you're wrong, right? Just pick C and move on, right? Don't waste any time on multiple choice. It just means that you didn't see the shortcut, right? Or the obvious way of getting the answer. And in multiple choice, there are very often opposite ways of getting an answer. And then you have section 2. Now, section 2 questions are going to involve you doing a lot of work. If I just see an answer to it, I'm not going to give you any points because you could have simply just cheated in some way that I'm not aware of. But if I see working, that's a good indication that you know what to do. Secondly, if you do the right working, but you know, you lost a sign somewhere, or you wrote down 3/4 when you meant to write down 3/5, you get a fair chunk of points, right? So you'll get partial credit, as it's called. So 10 multiple choice would be
I have a question.
pretty good. And off the top of my head, now I've got it in my thought process, somewhere around about 10 questions in section 2. So that's what I'm thinking.
So
yes, Jason.
For the parts where we'll be showing our work, so are we just writing it on a blank piece of paper where we would write like A for multiple choice answer?
Yeah, let me kind of pretend that I'm doing one of my own midterms. This is what your piece of paper would look like. Right. You tell me your name, even though I can find that out from where you upload it, but it just makes it easier. And you would say, question 1 was A, question 2 was C, and you finish with question D and you thought it was E, right? So that's what I would see written down. And then you would do section 2, the ones I just showed you. And section 2 had some kind of, I don't know, right angle triangle. And you do a whole load of working. And then you'd find the missing angles 32.5 degrees. So I would see the triangle, I'd see all the working that you use to get the missing side. And for instance, in this case, the missing side would be the square root of 34. And eventually you found the missing angle and boom. So all of this I would see. And the way, how do I get to see it? I guess is a good question as well. You get your phone, like I have here, and I should be able to actually kind of sort of show you. It's, oh, my sister from Scotland left me a message. That's cool. Or I should say one of my sisters. And give me a few seconds. I'll find the program.
So
It's
I
called,
actually have one that's called Cam Scanner.
yeah, Cam Scanner's fine. Use that.
All
You
right, so
don't use
I
mine.
use Adobe Photo Scan.
Yeah, I'm just doing Microsoft Lens because that's the one I've put online that you can upload. I'm having little phone issues because just being a pain because technology does that. Don't want the camera. I'm going to find it again. It's called Lens. Okay, I think it's this one. Okay, so I got my thing, and this is my version of the program. You basically, you just, I don't know, you hit, well, in my case, document, you hit that little button, takes a picture, you move it around. When you're finished, you can adjust it a little bit, tweak the corners, make some go up, in case you missed a bit, right? You got all your work in. Once that's done, you confirm. Once that's done, you can do done. In this case, I have, I can send it to my OneDrive, which is probably the easiest if you've got a OneDrive, but you could convert it into a PDF, right? And you could store it on my OneDrive, or if you store it on your phone, you can do that. Let's suppose that I stored it on my phone. Hit save. There we are. Now, if I want to send this to you, right, you would then you would go into Canvas, and there'd be a place that will be called something like upload your working here, and you'd upload it. Now I have some videos telling you how to do all that stuff, so don't worry if you can't pick it up. But you would put all your working down here, and you would get back your midterm grade. So can you see that I don't need WebAssign to do any of this? This is my version of you turning up to class and I hand you the test and you write it down on paper and you hand me the test back. This is the online equivalent of doing that. That's why I need to see you, because I want to make sure that you're doing it and not anyone else is doing it. Right, so that's important, you know, that we're all getting treated the same and it's fairly done. And what else? There are 2 time slots for this class. All right, not 2 time slots, take that back. We will be doing it during our class time. That's what I meant to say. And in our case then, won't that be 1 to sometime after 2, 2:15, 2:30, and we'll all wiggle room there. Are we cool?
What day of the week is that? I haven't been able to check.
It's Monday. It's this coming Monday.
Okay, thank you.
So this coming Sunday, you've got online test 5. That's good practice because a lot of the types of things, you know, 1/5 of the work roughly, but, you know, is coming from that section. And I think I've answered all the questions I can think of. So it's your turn now to ask me some questions because I didn't think of them.
So are we supposed to print this test out and write on
Nope.
it?
No, just write out the answers on paper. What you can do is on the screen, you can read the question, just like I had there a few seconds ago.
Uh-huh.
So you would read question 1, you might draw the picture that goes with it, and you'd write in your piece of paper. And that's it. And so when you're finished, you might have 6 or 7 pages of working to do what I just did. Now, in that one that I just did there, you can actually do them all in one go, right? You can take a picture, keep it, take the next page, keep it, take the 7th page and keep it, and then just have one single file to show me at the end.
Yeah, as long as we just need to number them correctly.
Well, yeah, that would help. I guess I would know. Well, I should know as long as you make sure the questions are right. When you're doing your midterm exam, it's a good idea to have a strategy that at least I found successful. So I'll give you some of the clues or some of the hints. Multiple choice, you only need to show me the answer. So if you know shortcuts, ways to use Desmos to get the answer a little bit quicker, right? Things that might help you solve them, do it, right? All of those are totally cool. If you don't know the answer, Grace told me, because she's doing it with telepathy, that she's picking C. So when you don't know a question, it's called C. That's much more efficient than spending 20 minutes trying some stuff that you kind of know doesn't work, but you're hoping that maybe the right idea will pop into your head. Not good use of your time. If you don't know it, C. Now, if you don't, if you finish early, go back and have another look. Maybe some will come to you by then. But section 2, spend a few moments looking through the questions. And I would suggest that you do the questions in the order that you know them. In other words, if the best question, the one you know how to do in your sleep, is question 9, do that one first, right? So do them in the order that is easiest. Now that doesn't matter to me, because can't you do each one in its own piece of paper? So you can shuffle them back when you're finished. So it won't cause me any problems. And then keep the horrible ones that you know you don't really do well at, right? So I don't know what that is, because it's different ones for different people. So Jason hates, you didn't know this because I've made it up, Jason hates amplitude, period, and phase shift questions. He keeps on getting them back to front and upside down, and he knows that's his weak point. Don't you make that your last question then, Jason? Because you can spend as much time as you like trying different things to make it work before you commit to the final answer, right? If you do your questions on separate pieces of paper and you screw up, can't you just throw away that piece of paper and start on a fresh one? So try and keep the section 2 questions to one piece of paper each, and that'll just make your life a lot easier. That's about it. Oh, your test will be in chronological order, which means the first questions are from week 1 and the last questions will be from this week. So if you look at a question and it's question number 9, it's probably from this week, right? And if it's question number 2, it was from week 1, roughly, right? So don't try and do a technique that you learned this week to answer a week 1 question, right? They probably aren't right. Okay, more questions. What you got? Okay. Once I've got myself organized, when you go to Canvas, there will be a new module. I'll put it at the top, and it'll be called something like midterm exam information. And inside that midterm examination, I will put Desmos. I will put that practice one for you for right now. And I will put an assignment thing. And basically, you upload your working into an assignment, right? And I'll put a practice one in there that you can just doodle pictures and upload it. It doesn't matter to me because I don't look at them, right? But just so you get comfortable that you know how to take pictures of stuff and you know how to upload it. The last thing you want to do during the stress of a midterm is figure out you don't know how to do the software, right? So
and it needs to be in PDF, correct?
PDF, please, because that's what this the assignment is expecting. So if you try and put in something else, it's going to tell you, you know, I don't know what you're doing. That isn't a PDF. I'm not taking it, right? On the day of the final, the midterm, also this will happen on the final, because your final is going to look just like this as well, by the way, just bigger. All WebAssign questions will disappear. You won't be able to go into WebAssign and see anything. You will be able to see your ebook, but nothing else, right? Also, anything, i.e. videos in Canvas, all disappear. The only module that will exist will be called midterm information. And when you go in there, the practice one I've gave you will have disappeared as well. So all you will see on the day of the midterm is a link to the Zoom, because there's a special Zoom meeting for this class, for the midterm. The place where you upload your working, Desmos, and a PDF, right? You click on it, just like I did, and there's a PDF of all the questions. I feel much better now. I think I've actually covered everything. But have a shot at it. Anything you want to know that I may not have covered well.
So you said it's going to start at 1, like the usual time, right?
Yeah.
On Monday.
Yep. And what will happen is there'll be a timer on it. See the PDF where you get your questions from, right? That will cut out around about 2:15. I might move it to 2:30 if the test seems to be taking longer than I thought it should do. If you're interested in where I get the questions from, I typically just look at homework questions or book, questions from the book. So there shouldn't be anything too weird or wonderful. Since I got a few moments, more than I was expecting.
As long as there's not one of those questions where you're given the weird numbers and you have to figure it out using A.
I don't know. I can do
sign.
that. I can do that. That's okay. I feel comfortable with that. Right. Well, guess what? If I give you one of them, that will be your question 10, won't it? That'll be the last one you do.
Will.
Right. So that's it. But then you'll have passed. You won't really be too worried. Right. So to give you an example, if I can make that bigger, it would be helpful. No, that's as good as that's going to get. Okay. Can you see this question here? Is actually, do you remember the homework question about looking up to see the radar and looking down to see the ground? Do you remember those ones? That's my copy of the same kind of question. You remember the one I did about trying to find the height of a castle wall? I did a story about that. That's basically my version of that. We did one about somebody traveling northeast. Remember the plane one? That would be my version of that. Looks like I haven't done any of the stuff that's this week's, but you're going to get a practice, You're going to get an online test 5 of that, and that's going to be fresh in your mind with homework. So I don't think I need to worry about that. So that's what your questions are going to look like.